Next, we talk about the ethics. This is related to the understanding and the level of practice. If you look at the definition here, it is not just awareness. They are also looking into the levels of practice of these ethical principles. Looking at the statements here, apply ethical principles and commit to professional ethics and norms of engineering practice, and adhere to relevant national and international laws. You will see three components here. The first one is apply the ethical principles. The second is to commit to professional ethics and norms of engineering practice. The third, adhere to relevant national and international laws. Not just applications, they are also looking into the commitment, as well as carry out the obligations within the boundaries of laws, nationally and internationally. And then demonstrate an understanding of the needs for diversity and inclusion. This is about the ethics. The relevant knowledge profile, it will be WK9. WK9 is related to the ethics and conducts. Next, it will be individual and collaborative teamwork. This is about the roles in and diversity of team. Looking at the definition here, the engineer graduate need to function effectively as an individual and as a member or leader in diverse and inclusive teams and in multidisciplinary, face-to-face, remote and distributed setting. Not only the engineer graduate can function effectively as an individual, he or she should also function well as a member or as a leader in teams. These teams can be highly diversified in terms of the members or in terms of the disciplines. An engineer graduate should function well in a team under various settings, whether it is face-to-face or remote or distributed settings. Next is about the communications. The levels of communications according to the type of activities performed. That will be WA9. Communicate effectively and inclusively on complex engineering activities. When we see the terms complex engineering activities, there is proper definitions of complex engineering activities. These are the attributes. And activities is considered complex when it has at least two of those attributes. Otherwise, it is not considered complex. This is the only graduate attribute related to complex engineering activities. And then let us proceed. Communicate effectively and inclusively on complex engineering activities with engineering community, with society at large, such as being able to comprehend and write effective reports and design documentations, make effective presentations, take into account cultural, language, and learning differences. That means now the communications is not only restricted within the engineering community. The engineer graduate should have the ability to communicate with the society. There are significant differences between the engineering community and the general society. Particularly, in terms of the engineering and technical knowledge. The engineer graduate must have the ability to communicate professionally among the technical groups, that means engineering personnel, and he or she should also have the ability to make complex things simple, effectively delivered to the society, especially for those without technical and engineering background. And then the following outlines the requirements. Having the ability to comprehend, to write effective reports, to design documentations, to make effective presentations, taking into account cultural, language, and learning differences. This is quite a thorough way of communications, using proper techniques to communicate to different groups of people of different levels of education background. It is not only restricted to the comprehensions and writing report, it is also not only limited to the presentations. We are also looking into the ability to design documentations to facilitate or stimulate the communicating process. This is about WA9. Next, it will be the project management and finance. We are looking at the levels of management required for different types of activities. This is WA10. Apply knowledge and understandings of engineering management practices and economic decision making, and apply those to one's own works as a member and leader in a team, and to manage the project in multidisciplinary environments. This is about engineering management, taking into considerations on the economic aspects, not only about the knowledge, also has the ability to apply those in various ways, such as in their own works, as a member or a leader in a team, to manage the project under the multidisciplinary environment. What you see here now, the graduate attribute, there are common terms appear here and there. One of those, it will be multidisciplinary. You see this term in WA10. You also see this in WA8. That means engineering is not an isolated field. Even the disciplines of engineering normally does not stand alone in a project. There will always involvements of engineering from various disciplines. It may also involve non-engineering disciplines. Having the ability to perform well within the same discipline is one thing. Now the requirement here, you should be able to function well also under the multidisciplinary environment. The last graduate attribute, it will be WA11. This is about the lifelong learning, which is closely related to the durations and manner. Recognize the needs for and have the preparations and ability for independence and lifelong learning, adaptability to new and emerging technologies, critical thinking in the broadest context of technological change, as this is considered a part of the graduate attribute. That means they are also looked into serious on this matter. There should be continuous lifelong learning come within the engineer graduates. There should be independent lifelong learning. This is to stimulate the growth in terms of the knowledge related to engineering, as well as the new and emerging technologies. This should also involve critical thinking in the broader context of the technological change. having the ability to foresee the emergence as well as the developments of the technology. Now, if you read through every single graduate attributes here, you will see that the expectations is rather high. There are so many components to be covered. The depth and complexity is being clearly stated. The scopes and behavior are also clearly outlined. The levels of thinking orders are also being reflected. These attributes not only look on the technical and the knowledge aspects, there are also practical aspects involving the usage of the tools. There are also affective aspects such as ethics. Some may have combinations of cognitive and affectives, such as the engineer and the war. There are also other skills, such as teamwork skill, communication skills, project management, finance, and they are also looking into the lifelong learning. Now the question here is, you will have this graduate attribute as the program outcome. If you analyze the context within this graduate attribute, if we can produce graduates having all these attributes, it is likely that we are producing super engineer. That will be our ultimate goal. Now the next question is, we will need to make sure that our program, especially the curriculum and the teaching and learning activities, are really well designed, meeting those graduate attributes or the program outcome. Theoretically, you will have to analyze your curriculum, check your curriculum whether all the components in the graduate attribute has been satisfied. Any missing items within the curriculum. Theoretically, you should do that. But just to do that, it is really massive work. My personal observation, many universities and many programs do not actually went into analyzing every single component as stated in the graduate attribute. Now the common practice it will be, when they design their course and the course outcome, they make sure that parts of the graduate attributes are being fulfilled. This is easier ways to do it. As long as they can make sure the respective course outcome are strongly correlated to the program outcome, which is the graduate attribute, it is good enough. Personally, I still feel that we should at least try to analyze the components within the curriculum to see if we accidentally miss any item here. For example, normally when it comes to the design of solutions, many do not consider the economical aspects. Considering health and safety are common. Considering the economic aspects are quite rare. Considering the carbon, not at the moment. Since now we have incorporated the Sustainable Development Goal, I will foresee that this shall be incorporated in most of the university's program in future. How about the cultural and societal? I see this is quite limited. If we really need to be so precise up to that level, many might not have this. Many have the difficulties to incorporate this. Since the philosophy of outcome-based educations, it will be the CQI, continual quality improvement. We can improve the program bits by bits. For the first round, when establishing a curriculum, you make sure that you have most of the components as outlined by the graduate attributes. As the program runs over a period of time, probably you can do some analysis, see if there is any lacking of certain essential components to be incorporated within the curriculum. I believe there are always misalignment between the full statements of the POs versus what is actually being incorporated within the curriculum. It is very likely that certain components have been quite heavily delivered, while some others may not even be touched by any of the courses within the program. This comes to the importance of curriculum review. And then you also see a lot of common terms there. At least what we have noticed, there are series of knowledge profile outline. There are complex engineering problems. That means you really need to look into the characteristic of the problem in order to define the complex engineering problems. It cannot be simply any problem. There are also complex engineering activities. Again, you will need to look into the attribute and the definitions of the complex engineering activities. It cannot be simply any activities. You might want to look into also if your program as a whole covered all the complex engineering activities. Is there any missing item? And preferably, all type of complex engineering problem should have also been incorporated. Is there any missing item? And also look into the knowledge profile and the attitude profile. Any of those missing? And in the graduate attributes, there are also sustainable development. You will need to make sure the sustainable development goals are incorporated. You should cover as many as possible, which is relevant to the engineering program. Some sustainable development goal cannot be achieved or is not that closely related to engineering. Probably you can leave it. Focus and pay attention to those more closely related to engineering. It is also highlighted that of multidisciplinary involvement, especially when you talk about the communications. It is not only restricted within the engineering community, it should also involve the society. How to communicate effectively in two ways with the society whom do not have engineering backgrounds and technical knowledge.